All right, boys and girls. I left you an assignment that is due on Friday, January 22nd, that involves answering the odd-numbered questions on page 2 of this second handout that I put on the announcement. This topic is in regards to naming compounds containing transition metal ions in a different way than we've previously seen. Just looking at this particular handout, you'll note that there are two different columns in this little table at the bottom that gives you two different names for each of the transition metal ions listed. One is called the stock name that we've already have used, that requires us to put in a Roman numeral in parentheses indicating the charge of the ion. But there is a second way. They call it the classical naming system, and that's what we're going to be taking a look at today. All right, first off, we should realize what we're dealing with here. Ionic compounds are combinations of metal atoms with non-metal atoms, typically. All right. The metals are all of the elements that are on the left side of the periodic table. We could actually draw a staircase shaped line down through the periodic table. It looks like that, with the non-metals all over here. These are the non-metals. And the metals are on the other side, but the metals can be divided up into two groups. Those metals that always form an ion of known charge. For example, the alkali metals, lithium, sodium, potassium, barium, cesium, francium, are always plus ones. Beryllium, magnesium, calcium, strontium, barium, radium are always plus twos. Over on this side of the paper, in group 13 or group 3A, aluminum, gallium, indium, thallium are always going to be plus threes. Right? The metals in the middle, the transition metals, however, have several ways in which they could form ions. Right? For example, iron could be a plus 2 or a plus 3, cobalt 2 or 3. The list of those I included on several handouts that I put on Google Classroom already. The most comprehensive list is known as the multivalent cation list, and it is 3 pages long. 1, 2, 3 pages long. All right. So if you could dig that up off of Google Classroom, maybe not a bad idea. Print it out and put it in your notebook if you can. I printed or gave you a link to this one. All right, it's got polyatomic ions on the front, but on the second page, there's a short list of these what are called multivalent metal ions, or metals that can have more than one charge. And of course, the list on the handout that I put on Google Classroom today. Right. Now, just one last little point on these transition metals. There are groups of metals here that we should say something special about. The first is zinc, cadmium, and silver. Even though they are transition metals, they are not multivalent. Silver is only ever a plus 1. Cadmium is only ever a plus 2. Zinc is only ever a plus 2. So we don't have to use any kind of special naming rules for these guys. So we could just, sort of forget about those in terms of needing to use a stock system or a classical system of naming. They're just zinc, silver, cadmium, no Roman numerals, no ic or us ending. On the other hand, there are 3 metals, tin, lead, and bismuth, that are outside the transition metal region, which behave as if they were like transition metals in that they have 2 possible charge states. Tin, for example, could be 2 and 4. Lead, I believe, is 2 and 4 also. And bismuth, I don't remember that one offhand, but you can look, I think it's 3 and 5, if I'm not mistaken. So just keep an eye out for those guys. All right, good enough. Let's get on with doing a couple of example problems from today's assignment. Okay. Again, there are problems 1 through 48, except all you need to do are the odd numbered problems. Let's take a look at problem number 1. All right. The formula is given to you as Cu2SO4. All right. Now immediately I see that copper being a transition metal. All right, copper's right here. This is a metal ion that I need to figure out its charge in order to properly name it. If I use the Stokes system, it's going to be copper, and then in parentheses a Roman numeral indicating its charge, and then the name of the anion after it. Right? This is a polyatomic anion. Right? It's not just sulfur, not just oxygen. It's a combination of sulfur and 4 oxygens. And here you just have to look these guys up. Right? Here's my list of polyatomics. All right. When I look this up, SO4, 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 it's right there. SO4, and it's got a -2 charge, and it's called sulfate. All right. So SO4 is a -2 charge. All right. Its name's sulfate. All right. And there's only one of them here. All right. If there were more than one sulfate, I would have parentheses around it and a number outside. If it was SO4 with parentheses and a 2, the way we normally say this is SO4 taken 2 times. Right? But that doesn't exist here. Since there are no parentheses and there's no subscript outside, there is only a single sulfate anion with a charge of -2. All right. So here we'll say sulfate, -2. All right. How many coppers are there? Well, Cu2. There's 2 coppers, so there's a copper and another copper. All right. And these both have a positive charge of some magnitude on them. Well, the magnitude of the charges on copper have to be equal to the magnitude of the charge on sulfate. If sulfate's a -2, then these 2 coppers here have to be a total of +2. All right, which means that each one of these coppers is a +1, or a 1+, however you want to write it. Therefore, this would be known as copper 1 sulfate. Okay, now that is the stock naming system. The instructions on this sheet were to name these both using the stock system and the classical system. All right. So if we get out our list of transition metal ions, either this list or if you want to use this one out front, let's use the page 1 of the same assignment. All right, copper with the +1 charge, it's the very first ion on this list. Copper 1 ion is also known as the cuprous ion. So that means that this would be cuprous sulfate. All right, here's the stock name. And here's the classical name. Copper 1 sulfate or cuprous sulfate. Okay. Let's try number 11, Fe2S3. Fe2S3. All right. Fe is iron. This is going to be a transition metal. All right, iron's right here. So therefore, we're going to have to find out what its charge is and make it a Roman numeral and put it in parentheses. So iron's something. And then what's S all by itself? That's sulfide. All right. This is not a polyatomic ion. It's what's called a monatomic ion. And monatomic anions always end in IDE. So sulfur is sulfide when it is part of a compound. And sulfur is right here. Because it's 2 jumps away from the noble gas column, I know its charge is always -2. Right? -2 or 2 minus. Let's make it 2 minus on the sulfide. But there are 3 of them. So if we say sulfur, 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 2 minus, 2 minus, 2 minus, that gives us a total of 6 minus, which means that the 2 irons, let's see, Fe and Fe, whatever they are, have to be 6 positive. Well, what does each iron have to be? If the total is 6 positive, it's got to be 3 positive. All right. Now, if you follow that lesson on crossover rule or the crisscross rule, you can see that this charge of 3 plus is really reflected down here as the subscript on sulfur. Right? And for that matter, the charge on sulfur, which I know is a -2, is reflected down here as the subscript on iron. Now, this crisscross or crossover rule you have to be careful with because it doesn't always work. But we should be able to at least see that working here also. Anyway, each iron is a +3 in this particular case. All right, so this would have to be called iron 3 sulfide in the stock system. But what is the classical name of the iron 3 ion? Right, the sulfide's not going to change. Right, the back half of the compound is going to be the same name. It's the transition metal ion that has a change in name. And if I get my list of transition metal ions out, iron with the +3 charge is called ferric. Ferric sulfide. So there you go. All right, and let's do one other, number 33, which is tin 2 iodite. Right? Notice that this is an ITE ending. As soon as I see the ITE ending, I know it's polyatomic. Ites and eights are always polyatomic. If it's an ide ending, then it's probably monatomic. But let's just stick with the ite and eight endings being polys. What is the iodite ion? Well, if I look it up on this list, it's right here. Iodite is IO2 -1. Or 1 minus. Tin 2 means tin with a 2 plus charge. All right. I would need another iodite ion with another -1 charge to balance out my charges. 2 -1s give me a total of -2. The tin is, I'm told, is a +2. All right. So the pluses and minuses are the same. So 1 tin, all right, and 2 iodites is going to be SnIO2. Now the IO2 has to be in parentheses. I need 2 of them, so I need to put that 2 down as a subscript, but it's got to be outside a set of parentheses. All right, so there we go. Now we were also asked to name this in the other manner, the classical naming system. Tin 2, just look it up on this page. Tin, here's tin 2. That's called the stannous ion. So this would be stannous iodite. And there we go.